Welcome to section 4.2. We're talking about the unit circle. Before you start this video, please make sure that you actually watch the unit circle video so that we can continue to fill in all of the unit circle from radians, degrees, to also exact values, because we're working with the exact values today as we fill in our notes. Now, what I do want to start with, though, is the basic idea of the unit circle. And we looked at it on a coordinate plane, and this is what we filled in the notes, where we knew the four main axis points were 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we started to fill in radians and degrees from there, and then we said, okay, you should know three main values, 30, 45, and 60. And if you could remember the pattern, we could go from there. Now, what I want to do is show you the general idea. If I take the radius of this circle, because it's a unit circle, the radius is 1. And what I can do then is make a triangle with the x-axis, where I know that this angle on the inside is theta. Going from here to this value is x, and then going up is y. Therefore, this point is a point xy. And so I want to start with some of the ideas from geometry that you learned, where we said the sine of an angle is the opposite over hypotenuse. And we learned a phrase, SOHCAHTOA, and we're going to do this more in depth tomorrow, but I want to start with that idea. Sine is opposite over the hypotenuse of my triangle. So the opposite is y divided by the hypotenuse, which is 1, which basically means the sine is the y value of a point. The cosine of an angle is the adjacent over hypotenuse, according to SOHCAHTOA. The adjacent is the value of x. My hypotenuse is 1. Therefore, the cosine is the same thing as the x coordinate. The tangent we talked about yesterday was sine over cosine, but I'm going to skip that. If we go back to tangent, tangent is opposite over adjacent, so opposite over adjacent is y over x. The biggest thing, though, is tangent has to be defined, therefore x can't be 0, or I have an undefined fraction. And we're going to be talking, too, in the next couple of sections about their reciprocal functions. Those are in your book. I'm going to leave them for right now, but those will come up. So basically, if you look at the x-coordinate of the unit circle, that tells us the cosine of an angle. And if you look at the y-coordinate, they're talking about the sine of an angle. And that's one thing that we filled in on the unit circle, so that we knew that every coordinate point you could find x and y. Now, I'm going to pop up the unit circle every once in a while, and I have already filled one out, but at least then you can kind of see what we're talking about. So let me slide us down a minute, and let's actually find a few of these. And I'm going to kind of jump around a little bit, but we'll look at them. If you look, we're asking you to find, in this case, sine, cosine, and tangent for 3 pi over 2. Okay, I'm going to start by drawing a picture. 3 pi over 2 is the same thing as 270 degrees. So this is 3 pi over 2 down here. This is the point 0, negative 1. Okay? So let's start listing them out. The sine of 3 pi over 2 is the y value. In this case, the y value then is negative 1. The cosine of 3 pi over 2 is the x value. So the cosine of 3 pi over 2 is 0. The tangent of 3 pi over 2, and this is more important, is the same thing as the sine of 3 pi over 2 divided by the cosine of 3 pi over 2. Okay, so sine divided by cosine. So sine is negative 1, divided by the cosine is 0. We get an undefined tangent value. And you will have tangents be undefined more than anything. Sines and cosines will never be undefined. So that's the idea. So let's take you through another one. 5 pi over 4, if you didn't know where 5 pi over 4 was, we could convert 5 pi over 4 into degrees. Now, if you look at your unit circle, this happens to be 225 degrees, which means it's down here. You will want to use your unit circle then to figure out what is the exact value for 5 pi over 4. So look at your unit circle a second. What you will find is it's negative square root of 2 over 2, negative square root of 2 over 2. Okay, so we're going to just start listing out our trig values then. The sine of 5 pi over 4 is negative square root of 2 over 2 because, again, that's the y value. The cosine of 5 pi over 4 is the x value, which is, again, negative square root of 2 over 2. The tangent at 5 pi over 4 is the sine divided by the cosine. Both of them are negative square root of 2 over 2. And when you divide something by itself, your answer then is 1. So this is kind of the idea as we go through. I'm going to do maybe, let's do one more together. I will do C, and then I want you guys to do D on your own. So let me scroll this down. And let's look at C, 5 pi over 3. Again, if you don't know where 5 pi over 3 is, 1, look at your unit circle, or 2, you could multiply by 180 over pi, and you could find that, in fact, this was 300 degrees. I like drawing the picture. I like knowing that 300 degrees is down here. Then I look at my unit circle, and I say, okay, it's the exact values of 1/2 and a negative square root of 3 over 2. And I like labeling it. You guys have your unit circles, though, hopefully in front of you, so you can look at that. So the sine of 5 pi over 3, and I always write it in the way they gave it to me. I'm not going to say the sine of 300 because they gave it to me as a 5 pi over 3. Sine is the y value, so y is negative square root of 3 over 2. The cosine of 5 pi over 3 is the x value, which in this case is 1/2. And I'm going to do C with you truthfully just for the tangent value because the tangent is the hardest part. The tangent is sine negative square root of 3 over 2 divided by the cosine of 1/2. And I do this one because we're doing fraction by fraction, and this is going to be truthfully no calculator. So as I look at this, I'm going to write it like this. Dividing by a fraction is the same thing as multiplying by the reciprocal of the denominator. And when I do that, the 2's cancel out. You end up getting the negative square root of 3. So tangent's a big one. Make sure you can go the other way. If I put a 1/2 on top and I divide by square root of 3 over 2, make sure you can do both. But this is the idea where we're asking you sine, which is the y, cosine, which is the x, and tangent, which basically is sine over cosine or y divided by x. Those are the big ideas. You've got to make sure you can be able to do all three without the use of your calculator. The only resource you have is the unit circle. Okay, so let's keep going down. As I look at the next page, we give you this idea of where is sine positive, where is cosine positive, and where is tangent positive. Okay, we have this little acronym where I look at it, and it goes, all students take calculus. What that means is we're telling you which ones are positive. So in the first quadrant, all 6 trig values are positive, and I'll emphasize the 6 more later. In the second quadrant, the only thing that's positive is sine, because cosine is negative. It's because cosine is the x, and therefore tangent has to be negative if you're dividing a positive by a negative. In quadrant 3, the only thing that's positive is tangent, because sine and cosine are both negative. If you divide negative by negative, you get positive. And in the last quadrant, the fourth quadrant, only is cosine is positive. And so, again, the way we remember it is all students take calculus. And you'll hear different versions of it. This is the one I use because it tells you, and again, you start at quadrant 1 and you say 1, 2, 3, and 4, and it tells you all sine, tangent, cosine. We'll deal with the reciprocal functions tomorrow. Actually, that's what all of tomorrow is working with those reciprocal functions. You knew them in Algebra 2. You're talking about secant, cosecant, and cotangent. Those then will fit into this all students take calculus, and we'll discuss that more. Okay? We want to look at this idea of domain and range in terms of sine and cosine, and this is kind of the harder part of it. And so what I want to look at, and I want to do this in two pieces. Let's start with the first one is f of x, and I apologize because I didn't even think about doing a g of x one, but let's do this, where we look at domain and we also look at range. Let's stick this in. Let's start with sine. Okay? Sine is talking about the y values. Now, in order to find the y values, what are we putting into that x? We are putting in angles. And so the domain that we put in are angles. The thing is, I can put in positive angles, I can put in negative angles, I can put in 0.5s, I can put in halves. I mean, you can do a bunch of different things. So this domain, I can put in any angle I want, which is all reals. Okay? The same thing happens though for cosine. Again, we're trying to find x values in this case, but I'm still putting in an angle, so again I can put in all reals. And the reason is we can write any angle as either a positive version or a negative version, although we like the positives better. Okay, then the question is, what is the range? What type of y values do we get out? Well, as I go to look at this, if you think about your circle, and let me draw it here instead of flipping back and forth, let's talk about y values. And I'm just going to go around the 4 main axis points, but I have this point 1, 0. Let me slide this, sorry. Let's do this so we can actually do it. 1, 0. This is the point 0, 1, negative 1, 0, and 0, negative 1. These are called the extremes. We're looking at the 4 main points. If you look at just the y values, let's start with sine. I look at y values and I go from 0 to 1 to 0 to negative 1. Everything in between, if you look here, is between negative 1 and 0. Everything between here is from 0 to 1, and everything in here is from 1 to 0 again, and everything over here is from 0 to negative 1. And so these are the extremes. These are the highest and the lowest that you go. So what am I looking at? The y's go between negative 1 and 1. You could write that in interval notation. Because they're included, I go from negative 1 to 1, including those endpoints. If you look, cosine does the same thing. 1, 0, negative 1, and 0. So for cosine, those x values, I go between negative 1 and 1 as well. This is important for us kind of as we go through, and let me, do interval notation for the first part as well, because we've talked about how that's important. So from negative infinity to infinity. But as I look at this, this is the idea, is that when you put in a value, the highest and lowest points that you get are from negative 1 to 1 for the y's and from negative 1 to 1 for the x's. What we're asking you in the next portion basically says, okay, what if I take f of an angle? Remember we said we put in an angle for x. Well, f is sine, so they're really asking me, what is the sine value at pi over 4? This is a value I expect you don't need to look at your unit circle for, because pi over 4 is the same thing as 45 degrees. The answer then is the square root of 2 over 2. If you put this as a decimal, you would find it's between negative 1 and 1. Okay? Now let me look at the second one. The second one says 9 pi over 4, and you've got to know where 9 pi over 4 is. Now, I don't looking at it. So here's what I do. I'm going to count pi over 4s until I have 9 of them. Pi over 4 is 45. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8, 9. 9 pi over 4 is in the exact placement as the sine of pi over 4. 9 pi over 4 and pi over 4 are the same thing. Remember, these are coterminal angles. The starting and ending place of them are exactly the same. This has one extra revolution. So this is pi over 4 plus an additional 2 pi. And so again, can I evaluate it? Yes, it's easier to evaluate by looking at the basic pi over 4 angle, but you know it's the same place. Again, this is the square root of 2 over 2. And so the idea of this is really to be able to take the idea of coterminal angles and see that their exact values are exactly the same. Okay. This is what talks about this idea of a period, and I'm going to keep moving down here a second. This is the idea of a period, where basically it says there exists a real number c such that if I take my original function, f of t, and I move it c places to the left or right, it's exactly the same thing as the original. And that just says basically I can keep going to that same number. This means that it is periodic. And we're going to talk about the period of sine and cosine as we go through. Because they are coterminals, the period, you know what, we don't want, let me erase this a second. We don't want periodic, we want the period of f. I apologize. The period of sine and cosine is 2 pi because they have coterminal angles. I can go all the way around the circle, whole revolution, and I can still get back to that same place. And we're going to talk about that both in the look of the unit circle, and also we're going to be graphing these functions as well in the coming sections. Okay. So as I look at this, the last part I want you to get you thinking, because this is going to come back up later, so I wanted to start. And I'm going to just draw the basic unit circle here a second. And I just want to be able to kind of give an indication. If I do the sine of an angle, is it equal to the sine of the negative angle? And you know what? I'm going to do 45 because I truthfully think those are easier. So let's do the exact values for 45. 45 degrees is the square root of 2 over 2, square root of 2 over 2. So this is 45 degrees. So let's also look at negative 45 degrees. This point down here is the square root of 2 over 2, but negative square root of 2 over 2 because my y value goes down. So sine is talking about the y values. So is the y value at a positive 45 the same thing as the y value at a negative 45? The answer is no. Okay. The second one says, well, let's look at cosines. I'm going to stick in terms of 45. The cosine of a positive 45 is square root of 2 over 2. The cosine at negative 45 is also a positive square root of 2 over 2, so our answer is yes. That means this function is even, and we've talked about this even and odd in chapter 1 before, and so it's coming back again in terms of trigonometry. The last thing is tangent. Remember, tangent is the sine over the cosine. So if I divide a positive by a positive, when it's at 45 degrees, I get a positive tangent. When I divide a negative by a positive, I get a negative tangent. So are these two the same? Again, the answer is no. So which functions are even? In this case, cosine is the even function. Its reciprocal function, which we're going to talk about tomorrow, of secant, is also even. And we're going to, again, I will hit more on that tomorrow when we start doing 4-3. But if the original is even, then its reciprocal function is also even. So keep that in mind. Biggest thing as you're going through your homework tonight, though, you have to use your unit circle. If you need extra blank ones, please ask, because again, you want to make sure you know the ins and the outs of that unit circle. Thank you for watching that section 4-2. If you have any questions, please make sure you're ready in class for those questions.